My name
is Ashton. I'm a senior engineer on New Relic's query language team, and today I've got a particularly cool advanced NRQL query feature for you, subqueries. So we're going to kind of focus in on how this feature can help you dig into New Relic's transaction data. So transactions are a pretty common data type here at New Relic. This kind of just reflects a request in the system, hitting a single service. You can see we have a decent number of transactions here, but what if we wanted to find transactions that are particularly slow, like something like, below average? We could do something arbitrary, like pick, transactions that are greater than 1 second. And that will narrow things down, but it's arbitrary. How do we know this is actually bad, like below average compared to other queries? You could dig into it. You could do research and analysis to figure it out. Not too difficult, but it would require a decent amount of manual intervention. So something you could do is, run a query to figure out the average duration. The actual average is a tenth of a second. So what this new feature allows you to write a query within your query. So now we are actually looking at the count of queries, or the count of transactions that are greater than the average duration. So this is a much better reflection of what is a below average transaction in the system. And we can even do better. We could make this inner query since 1 day ago. So this outer query is still since 1 hour ago. We can see that here. But the inner query is since 1 day ago. And this gives us a comparison of our current transactions against the last day's average, which can be particularly useful when you're trying to find, is there a lump of transactions that are well below average. But we could also use this as a delta in the select clause. So if we did average duration minus this query, then this will give us our duration delta. So in this case, we can see any of these spikes are our system saying these transactions are running slower than the last day's average. This can be really useful to dig into the system and see trends that are actually relative to your your average. But this feature is not limited to just targeting a single event type within itself. You can also target other event types. So another common data type is transaction error. So what if you wanted to see the volume of transactions that are going to services that are producing errors? So if we did something like unique count or uniques of entity good, this is a list of our current services that are producing errors. So what you can do is and use in. So in this case, this query is returning this list of entity goods, and we're saying I want transactions where their entity good are in this set of entity goods. And this immediately shows some incredible power across our system, because entity goods are used across all sorts of data types, spans, page views, all sorts of things that you can connect your data with entities that are across data types. And this combination of them, this ability to pull them into each other is very powerful. So if we did something like facet app name here, now we are seeing the actual list of accounts. And actually, let's fix this to being a pie chart. There we go. We can see the count of transactions that are going to services that we know have transaction errors. So this type of association across event types can be really, really powerful. And we can even combine the two things we were just looking at. We could say, there we go. You can see pretty quickly, these queries can get pretty gnarly. So to fix that, we've introduced a new feature in the query builder, Shift Enter, that allows you to introduce new lines, which is very, very useful with a feature that allows you to write substantially more complex queries. So we can kind of space this out, and now we're a little more readable. So this now is finding the average duration of our queries against the daily average for transactions that have transaction errors. Let's take a look at that. Let's jump over to a table. In this case, we can see the relative differences of these services against the last day for services that are producing errors. So this is kind of just scratching the surface at what this feature can do. I would definitely suggest, if you're interested in this and think you have use cases for connecting data across data sources and across different event types, different time ranges, go check out the new documentation and the blog post. It should be linked below. Great, thanks.